1.10, probability using Venn diagrams. So we're just going to recall the equation for the probability of event A occurring. And it's capital P for probability, capital A for event A. And it's just the number of times that A can occur over the universal set. Okay, so example 1. The Venn diagram on the right shows the number of students in a class who subscribe to Netflix and Disney streaming services. Okay, find the probability that a randomly drawn student, subscribes to Netflix. So, probability of Netflix is going to be, so what we want to do first is we always want to find what is the total amount of people. So, in this entire box, because this is the entire universal set, we're going to do 16 plus 8 plus 7 because those are all of the numbers in there, okay? So we know that this is going to be over 31 people. Now, subscribing to Netflix, and I'm going to color code this with red. It's everybody in this circle here. So essentially it's 16 plus 8. And that's 24. Okay, so 24 over 31, or out of 31 students, subscribe to Netflix. Okay, what about Netflix and Disney? So for B, we're going to do the probability of Netflix and Disney. So we're going to use that intersection notation. So the intersection is going to be here in the middle. We get 8. That's simply 8 over 31. And now let's do purple. Okay, so subscribes to exactly one streaming service. Okay, so probability of one service. Okay, it's going to be over 31. Okay, so these are the individuals only Netflix. These are the individuals only Disney. We're not going to include this 8 because those are individuals who subscribe to 2 services, which is both of them. So we're simply going to do 16 plus 7. Okay, you can go ahead and skip the part where you show the work. So just 16 plus 7, I get 23. Okay, so 23 out of 31. Okay, example 2. The Venn diagram on the right shows the number of applicants to a job who are proficient in Excel and then Python. Find the probability that a randomly drawn applicant is proficient in Python. So probability of Python, okay? So first we want to get that total. We want to get that denominator if it's asking for a probability. So we're going to go ahead and add every single person in the entire box, which is 37, 12, 22, and 5, okay? And what we're going to get is 76. So our denominator here is going to be 76. Now, Python. Python's this entire circle. We're going to have to add 22 and 12, and we get 34. You don't have to show that work. Now, proficient in either Excel or Python. Okay, so this is Excel or Python or both. Okay, it's not exactly one. It's going to be Excel or Python, and we're going to use this union notation. So the survey was still at 76 people, but this time we're going to include everyone in either of these circles. Okay, so here or here. So we're going to go 37 plus 12 plus 22. And we get 71. Okay, let's just clean this up a little bit. There we go. Okay, next one. Proficient in Excel and Python. So, Excel and Python. Remember, this is the intersection. That's going to just be where these two intersect, which is 12 out of 76. Okay, now purple. Okay, proficient in neither Excel nor Python. So not Excel, not Python, not neither, Okay, so Excel and Python are here. We're not going to use any of these people. On the outside, these individuals were still surveyed, so we have to include them. So these are individuals, so not Excel or not Python is going to be 5 out of 76. Okay, so a little bit different where we don't have a number in the Venn diagram that is outside of the circles, outside of the sets, okay, versus having a number outside of the sets. And now we're going to focus on the 3-set Venn diagram. Okay, so the Venn diagram on the right shows the results of a survey taken to see who the residents in a small town, who residents in a small town support in an election out of, okay, there's candidate X, candidate Y, and candidate Z. Okay, those are our 3 circles. Find the probability that a randomly drawn resident supports candidate Z. So, it's not number, it's probability. Okay, so the probability that they support Z. So, if we circle Z, we can go ahead and add 4 plus 16 plus 10 plus 111. We get 141 over, and now we have to do our total. So our total has to be everything. It has to be all of these plus the 125 plus the 22 plus the 168. Plus the 21. I get 477. Okay? And with numbers like this, I am going to just double check. And I get the same. Okay, 477. Pretty confident. Now, supports more than one candidate. So, these individuals support X and Y. These support Y and Z. And these support X and Z. So, anybody in those sections here, 22, 4, 16, and 10, they're going to support more than one candidate. Okay, so our denominator is still going to be the 477. And now we're going to add up these numbers. I get 52. Okay, what about supports all 3? So all 3 would be the probability of X and Y and Z. Okay, let's clean this up a little bit. And this is going to be the ultimate intersection. So taking a look at here, this is going to be 4 over the 477. Okay, D supports exactly one candidate. Okay, so these support 1. That's what we want. These support 2 right here. These support all 3 candidates. We only want specifically one candidate. So we're going to do the 125 plus the 168 plus the 111. And I get 404 over 477. Okay? And then E. So supports none of these candidates. Let's go ahead and do probability of not X or not Y or not Z. And I'm getting 21. So those are all the individuals outside of the circles.